And question 3, we've got a copper cable. It tells you it's connecting a starter motor to the battery, but that's totally irrelevant because all it's interested in, length, cross-sectional area, you don't even have to work that out, and they tell you the resistance. They ask for the resistivity. You can take a formula straight from the formula sheet, rho equals RA over L. Substitute in some numbers. Well, I've got a resistance of 1.6 times 10 to the minus 3. I've got a cross-sectional area of 7.9 times 10 to the minus 5. And I've got a length of 0.75. Follow that through. My answer should be 1.7 times 10 to the minus 7 ohm meters. Notice that there will be a mark for the unit in this case because they specify in the question. The next part moves on to think about EMF and internal resistance. So straight away you know what equation you're going to be using. You're going to be using the equation that EMF is equal to V plus IR. Now that equation isn't quite in the formula sheet. The formula that you're given is IR plus R, but you just need to multiply out those brackets and know that IR is equal to V. So we'll calculate the voltage across the terminals of the battery. Well, I'm going to rearrange and say that V is equal to E minus I little r. Let's substitute in some numbers. EMF 12 volts minus 420, which is the current, times 9.5 times 10 to the minus 3, which is the internal resistance, and that should give me an answer of 8.0 volts. 1 mark for substituting in the equation, 1 mark for the answer. Question 4 asks us to look at a circuit, so a combination of resistors. Very conveniently, negligible internal resistance, so we can ignore internal resistance in our calculation. So calculate the total resistance of the circuit. Well, first of all, I'm just going to worry about that parallel combination, and I'm going to say 1 over the total of that combination is equal to 1 over 40 plus 1 over 40 plus 1 over 20, which is 1/40th, 1/40th, 2/40ths, 4 over 40. Therefore, the total resistance of that combination is going to be 40 over 4, which is 10 ohms. For the whole circuit, I've now got that parallel combination plus that resistor, because they're in series, so my total will be 60 ohms. 3 marks. 1 mark for using that equation, 1 mark for working out 10 ohms, and 1 mark for the 60 ohm final answer. Calculate the current through the 50 ohm resistor. Well, thankfully, this is the easiest resistor to work with because this has the total current flowing through the circuit. The current will flow, it'll split into 3, but it will all recombine there. So I can just use Ohm's law for the whole circuit. I equals V over R. The total PD is 12 because there's negligible internal resistance. The total resistance of the whole lot is 60. 12 over 60, which is 0.2 amps. Really straightforward, which is why it's only worth 1 mark. Had they asked for the current through any one of those resistors, that would have been slightly more complex.